Good day, students. Today we're looking at the video solutions for practice 4. I picked out 3 problems. It's multiplying and dividing rational expressions. So we're going to have a look at these solutions. First one we're looking at here is number 8. This is on page 20. So as you can see in number 8, we have 3 rational expressions. 2 are being multiplied and dividing by the last one. So the first thing we're going to do is make sure we have it all multiplication. And we all know that dividing by a fraction is the same as multiplying by its reciprocal. So I'm changing that to 6w. Oh, got to flip it. So, okay, remember it's the reciprocal, so it's 5y squared over 6w. Okay, and let's change these multiplication signs to dots to avoid any confusion. Alright, with x's. Don't want to get them mixed up with any x's. So I'm going to change those to, we all know that means multiply. And of course the first 2 we just carry down. It's 8w cubed over 5x squared. Alright, multiplied by 3x to the 5 over 4y to the 4. Now everything here is multiplied. There are no binomials or trinomials to factor, so we can cross cancel right away. Now some people prefer to multiply the whole thing out and then reduce, or you can cross cancel, whatever you feel comfortable with. Alright, so I'm going to cross cancel as we are dealing with all multiplication. Now I'll look at the numbers first. Let's see what we can do with the numbers. I see a 5 here with a 5 there, so I can cancel both of those. Alright, 4 goes into 8 2 times, so I divide it, right? 8 by 4 to get 2. Then we have 6 on the bottom and 2 times 3 on top. So we can either cancel them now or multiply it out. It's up to you. Let's say we just multiplied those at this stage. We never saw the rest of the canceling. So we did 2 times 3. That's that 2 times that 3. And on bottom, the only coefficient left is this one here. So we get 6 over 6. And they'll cancel again after. Now let's look at some variables. What do we have here for our variables? First, let's look at the w's. I have a w cubed here on top. See it right there, and on the bottom I have a w over here. That's the only w, so that's going to leave me with w squared on top, correct? w3, because this is understood to have a 1 as a exponent. Looking at your x's next, I see only one x on top, x to the 5, and I see a, so here's your x to the 5, and an x squared on bottom. So subtracting, it would leave me with 3 x's on top, right? 5 minus 2. And the last variable left there is, of course, y squared on top with a y4 to the power of 4 on bottom. Subtracting those would leave me with, or canceling, would leave me with 2 y's on the bottom. And the 6's we can cancel out now. So our final answer would be, of course, just w squared x cubed over y squared. There's your final answer. Okay? And again, if you want to define where it is defined, y cannot equal 0, because that will make the denominator 0. So there's your first expression simplified. The next one now involves binomials as well as monomials, so be careful. You can't cross cancel right away. And remember, the only thing that cancels with a binomial is another binomial. Now you should start to recognize this. You should be able to recognize z squared minus 9. That's the difference of 2 squares. It's going to factor to z minus 3, z plus 3, and we've done that factoring before. Multiply by, and again I'll change it to a dot. Don't want to make any confusion here. 2w squared on bottom, it stays there. Now we don't flip anything here, we're multiplying. Remember, you only multiply by the reciprocal when it's division. And I see up here we also have a binomial, but I think you can all see that there's a 2 common in that binomial, right? So taking out the GCF, the greatest common factor, there's 2. I'm left with z minus 3. Now everything is factored. Now it's all multiplied. Now you can cross cancel. And again, remember, binomial with binomial. Complete binomial z minus 3 with the complete binomial z minus 3. I see a 2 here. Cancel with this 2. I also see w squared on the bottom here and w cubed on the top over here. And again, because it's multiplied, we can cross cancel those. That would leave me with 1w on top. So there's any numbers left? Yeah, we have a 3 left. We have w cubed over w squared, which would be w to the 1, or just w. Nothing else remaining in the numerator. On bottom, all we have left is z plus 3. And again, for clarification on defining, this is good for all z except negative 3. So z cannot equal negative 3. So there's a complete solution if you want to be proper in defining your rational expression. Now number 15, we can see a division sign again. So the first thing we're going to have to do is flip that. So I'll do that right away to avoid any confusion. So z squared minus 5z minus 14 on top, and z squared plus 7z plus 10. And over here nothing changed. I'll rewrite it one more time. 2z minus 15 all over z squared minus 8z plus 7. Now these 4 trinomials look to be factorable, but we'll double check each one. And again, when you're factoring trinomials, I'll just take the top one, z squared on the right. Top one on the right, see this? Z squared plus 2z minus 15. Now these are often referred to as a simple trinomial. A simple trinomial meaning that the coefficient of the squared term is 1. So it's simple in terms of factoring, if it's factorable. So you need a product of just the last number, because the coefficient of the squared term here is 1, right? Makes it a little easier to factor. So we need a product of negative 15 and a sum of positive 2. And this is going to factor to z plus 5, z minus 3. That way our product remains negative 15, p for product, and sum is, of course, positive 2. So those numbers are positive 5 and negative 3. Okay, so that's how I found those numbers. Now, all of these are going to factor similarly. I'm going to factor them quickly rather than this. And again, do not try to factor within the problem. Go to a piece of scrap paper, do your factoring, or do it on the side like I did, and just write the factors down in the problem here. Don't write anything else. Now, the rest of these are also simple trinomials. Let's see if we can do them quickly. Alright, there's no GCFs here, so I'm going to 2-bracket factoring because of simple trinomial skills, right? Now, z, positive 7, okay, positive 7 with a negative 8 middle term. The only way to get that is negative 7 and negative 1. Okay? Alright, that's going to give me positive 7 and a negative 8 in the middle. Negative 14, product and a sum of negative 5. I think most of you see that now. It's going to be z minus 7 and z plus 2. And a product of positive 10 with a sum of positive 7, z or z plus 5 and z plus 2. Now everything is multiplied. Now we can cross cancel, but remember again, complete binomial with complete binomial. So I see z plus 2, z plus 2. Done. What else can we see? Yeah, I think you mostly have seen it now. We had a z minus 7 here with a z minus 7 here. Anything else? I'm sure you see it. Z plus 5 with z plus 5. And z subtract 3 over z subtract 1 remains. We cannot cancel anything else. There's your final answer to make it complete. z cannot equal whatever makes a denominator 0, z cannot equal 1. So there's the final answer for number 50.